Hello viewers, in today's class we are going to solve one important definite integral involving absolute value function. So here we have to evaluate mod of 5x minus 3 and the limits are from 0 to 1, right? So let us first call this integral as I. Now in order to evaluate this function from the limit 0 to 1, let us make use of the definition of absolute value function. So here let f of x is equal to mod of 5x minus 3, and if we solve 5x minus 3 is equal to 0, then we see that we have 5x is equal to 3 and x is equal to 3 over 5, right? So here 3 over 5 is the critical point, and we can see that if we have this number line, this is 0 and this is 1, then 3 over 5 it lies somewhere here, right? So this is 3 over 5. So it implies that we have to break this integral into two parts, that is first from 0 to 3 over 5 and then from 3 over 5 to 1, right? So here mod of 5x minus 3 is positive 5x minus 3 whenever 5x minus 3 is greater than or equal to 0, right? And mod of 5x minus 3 is negative of 5x minus 3 whenever 5x minus 3 is less than 0, right? Okay, so here we have 5x is greater than or equal to 3, that is x is greater than or equal to 3 over 5, right? And here we have x less than 3 over 5, right? So it implies that when x is equal to or greater than 3 over 5, then the sign of this function is positive here, and this is the positive sign, and when x it lies between 0 and 3 over 5, then f of x is negative, so here we have negative, right? Okay, so now we can rewrite this integral I as a sum of two integrals I1 and I2, right? So I1 is from 0 to 3 by 5 f of x dx, and here I2 is from 3 by 5 to 1 f of x dx, right? Okay, so now we have 0 to 3 over 5, f of x is equal to negative, right? Because x lies between 0 and 3 by 5. So here we have negative 5x minus 3 dx, and here we have 3 by 5 to 1, and here we have positive 5x minus 3 dx, right? So here f of x is expressed as a piecewise function. So in these two intervals f of x has different signs, right? Okay, so now here we can write 0 to 3 over 5, and here we have minus 5x plus 3 dx, and here we can write the integral of 5x as 5x square over 2, and here we have 3x, right? And the limits are from 3 by 5 to 1, and here we have minus 5x square over 2 plus 3x, and the limits are from 0 to 3 by 5, right? Because the indefinite integral of x square is x square over 2, and here we have the integral of dx as x, here also the integral of dx as x, right? Okay, so now let us calculate the limits, and by substituting the upper limit and the lower limit and taking the difference, here also we have to write 5x square by 2 minus 3x, and the limits are from 3 by 5 to 1, right? Okay, so now first we'll calculate this expression. So we have minus 5 over 2, and for x we can write 3 over 5 square, and then we have 3 times 3 over 5, and then we'll substitute x equal to 0 here, so the both the terms vanishes here, so we have 0 only, and then we have plus, and here we have 5x square over 2 minus 3x, so substituting x equal to 1 here, so we have 5 over 2 times 1 square minus 3 times 1, and then we have negative sign, and we have 5 over 2 times 3 over 5 square minus 3 multiplied by 3 over 5, right? Okay, now we have to simplify this expression. So here we have 3 square 9, so we have 45 over 50, then we have 9 over 5, and then we have plus 5 over 2 minus 3, and here we have minus 9 5s are 45 over 50, and then we have this negative sign, and this negative sign becomes plus, so here we have 9 over 5, right? Okay, so now minus 45 over 50 and minus 45 over 50 becomes 90 over 50, and we can write, okay, so now we can write 9 by 5 plus 9 by 5 is 18 over 5, and this is 5 over 2 minus 3. Now let us take the LCM of 55, 2 and 1. Then here we'll have 50, and in the numerator we have minus 90 plus 180 plus 125 and minus 150, right? Okay, now if we simplify the numerator, then we'll have 180 plus 125 is 305, and minus 90 and minus 150 is equal to 240, right? And here we have 50, and if we subtract these two terms, then we'll get 65, and here we have 50, and if we simplify 65 over 50, then we have 5 13, 5 10, and we have 13 over 10, right? So viewers, here the value of this integral is 13 over 10.